All right, this is a little video on how to do, I guess, a mastery or a summative of your mastery of your learning about beat frequencies. So today it's kind of like a little lab, I guess, a little virtual lab, since we can't do this in class together with the tuning forks and the microphones, which is always a lot of fun. But we'll do what we can with this. And so what you've learned about beat frequencies is that they're the addition of two waves. Let's say you have two pure tones, like this tone, and they're close together enough that your ear can perceive what's called a beat frequency. Now, if they're far enough apart, they just sound like dissonance, and it just sounds like two bad notes that are playing together. But when they're close enough, you can actually perceive the beat. And in fact, those of you who are musicians probably tune your instruments sometimes this way by actually listening for the disappearance of the beat frequency when you're right in tune with somebody else. But in any case, those of us, that's how musicians would use it. It's also going to help us understand our learning for Monday, which is about harmonics and instruments and how all of their frequencies add together to give them their particular tone when they play a note. It's what makes like a saxophone playing the same note different than a flute playing the same note. So this is setting us up for understanding our learning on Monday before our summative on Tuesday. All right, but in any case, we have these two waves, and what you've learned is that the summation of these two waves create this beat, and what your ear perceives when these two tones are played together is this wah, 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 wah sound, right, which is the green wave that we're taking a look at here. So how can we analyze that mathematically, right? If we're going to look at that, how can we take a graph like that and calculate the beat frequency from a graph like that? Let's take a look. Okay, so you've done all of this. Down at the bottom, I've created a Desmos graph. So if you click on right down here where it says Edit the Graph on Desmos, go ahead and click on that. I believe you have the rights to edit some of these things and change some of these. And I'll double check on that. But in any case, you want to choose. So I have a 320 and a 330, and so the red wave is the 320. Right, and the blue wave is the 330, and that would be your hertz. That would be the frequency of the wave, or the pitch that you would perceive. Notice they're 10 hertz apart, and what I did is I wrote an equation that would be the summation of those two waves. So this is what you would perceive coming in your ear, and here is a beat. Okay, now that beat would continue over and over and over again with a certain frequency. So we would like to be able to calculate from this graph what is the beat. Now remember, this is an amplitude versus time graph. So we should be able to, from this time right here to this time over here, calculate the period of the beat by subtracting those two times. So here's what I'd like you to do. I would like you to be able to take a look at entering your own two frequencies. So for instance, I'll emulate what I'd like you guys to do. So let's say you choose 314. All right, and then you choose maybe a 334. Okay, so in order to see the beat of those two waves adding together, you also need to put them in the summation way. So 314, right, and then 334, and as long as everything matches up, you should be able to get your own unique picture of your beat. So here's what I'd like you to do. Okay, to analyze the graph, you might want to zoom in a little bit. Okay, and so that you can get a nice, decent sized picture of yours. And in your screenshot, try to include, if you can, well, at least write down these values, and then you're going to show me the calculation. So here's what you do. Take a screenshot, like Command-Control-Shift-4, and make sure you include the whole beat, like this. And then paste yours in a Word document, okay? And I'm going to put mine in Notebook so I can write on it in front of you. And you'll be able to write on yours, I guess, and you want to probably choose optimize or whatever here if you need to, because it's going to be a pretty big picture. So you're going to want to make it, my guess is you're going to want to make it be able to fit on the page. All right, so in the analysis of the beat, we know that the one frequency, I'm going to write those down right now. So the one frequency that we chose, okay, just as a quick reminder again, was 314 and the other was 334. And the other one is 334. So the beat frequency formula is very simple. It simply tells you that the beat frequency should be the subtraction of the two frequencies. It's the difference in the two. And so this one's pretty obviously going to be 334 hertz, right, minus 314 hertz, which is going to give you a beat frequency of 20 hertz. Now that's actually pretty high. Your ear might not be able to perceive that one. Okay, you might hear that as a tone, but this is what the beat frequency of the wave would be. All right, so here's how we can analyze this from the graph. Here's what I'd like you to be able to do, is we can read the period of the beats right from off of the axes. So I'm going to look at a symmetric part, right, to another symmetric part. So what I'm going to do is I'm going to pick this point right here, and I'm going to pick this point right here off of the axes. This will be my T2, and this will be my T1, right? The difference of those two times is the period that it took to make one beat. So if I take a look at this, right, this is 0.02, looks like it's right here, and this is 0.03, so every tick mark is going to be 2, 4, 6, 8, 10, right? So right in the center, it looks like I've got 0.2, 0.4, about 0.5. So this looks to me like it's 0.025 seconds. And my T1 looks like it's pretty symmetric, right? On the other side, it's going to be negative 0.025 seconds. All right, so now what I can do is I'm going to scroll down so you can see this a little bit better. Is what I want to do is realize that the period, okay, of my beat should be the difference of my two times there. That's the time it took to create one beat. So in this case, I'm going to have my 0.025 seconds minus my negative 0.025 seconds, which is simply going to be 0.05 seconds. Well, we already know that frequency should be 1 over the period. So if we do 1 over 0.05 seconds, there's our proof, right? That frequency is going to be 20 hertz. So my calculation from my graph, right, matches up with the formula for what the beat frequency should be if we know the two frequencies, and that's what I'd like you to do. Then what you can do is you can just either screenshot that and upload your little calculation from your Word document right into the maybe the media upload folder. That way it's a little bit easier for you maybe, or if not, you could submit it as a PDF, I guess, something like that. So that's it, and then take the little, I think, the little quiz on beat frequencies, and that's it, and then enjoy your weekend.